Hello everyone, welcome to Talking Here with Dr. Laz, your favorite health program on television, reaching you from Nigeria's capital city, Abuja. My name is Dr. Laz Eze. Have you wondered why some persons, when they are in the hospital and there are certain medications which could be antibiotics, antiviral, treating a certain kind of condition, and after a while it appears not to be working, then the medical team comes on a ward round, do their review and say, oh no, this appears not to be working. Let's do some tests in the lab. The test comes back to say, oh, the organism is resistant to the medication that is being used. And of course, when that happens, they have to change to another drug. Some of those drugs may be actually more expensive than the one that is being used. And treatment will have to start all over again. Of course, if you've not had a patient with a serious infectious disease, you may not have this experience, but a number of persons might relate to this. Is exactly what is caused by antimicrobial resistance. The World Health Organization has mentioned it as one of the top 10 public health risks in the world, and it causes a huge cost. Of course, leads to prolonged stay in the hospital, leads to complications sometimes, and of course some other unintended consequences. It's growing and something that needs very much attention. We've discussed this on our show before, and we are going to discuss it again because we never get tired until we begin to do the appropriate things to save ourselves, especially in this part of the world where people consume antibiotics as if it's food. Like I usually said, antibiotics is very good, is a lifesaver, but it can also be poison when it's not used appropriately. So that's what we are going to focus on the program today. The discussion is going to be deep because I'll be speaking with a researcher joining us from Preston in the United Kingdom, an associate professor, someone that is deep into clinical research. So if you have a researcher, if you have an expert in this area, they might have a lot to benefit from this conversation. But of course, there is a part that is for general knowledge. For non-professionals, there's also some component of the conversation that we get to use a lot of medical language. Please, if you get to hear that, bear with us, because in this program, we have everybody that get to watch. Some watch to learn, for the purpose of their professional practice, and we leave no one behind. We'll take a break, and when we return, we get into the conversation proper. You stay with us. Welcome back to Talking Here with Dr. Laz, your favorite health program on television. We'll be talking about everything you need to know on antimicrobial resistance. And to join me to have this conversation is Dr. Don Nwibo. Dr. Nwibo will be joining us from Preston in the United Kingdom. He's an Associate Professor, School of Medicine, Osaka City University in Osaka, Japan. Also Adjunct Professor, School of Health Sciences, University of the People in California, United States. Dr. Nwibo is a graduate of University of Nigeria, where he made first class in chemistry before he proceeded for a master's in pharmacology and medical microbiology. He did that at University of Tokyo in Japan. He also has a master's in business administration and a PhD in pharmacology and infectious diseases. He consults and does a lot of clinical research, especially as it has to do with antimicrobial resistance. And like I mentioned, this conversation is going to get research-like at some point, because Dr. Nwibo is very much loaded in the program. You're welcome to the program, Dr. Nwibo. Good to have you finally.
Thank you. Thank you, Dr. Laz. As I had said before, and I appreciate our viewers for the time they spend trying to understand some of these difficult things. It's the challenges of our time, and we would have to do all we have to do. But more importantly, is the discussion will be as simple as possible, because I understand some of our viewers are not inclined into research and all this microbial world. So we'll try to make it as simple as possible for everyone to follow. Thank you.
Thank you very much for that commitment. You know, I'd already pre-warned the, pre-warned the viewers that we could get to some points where they will hear certain languages they are not very used to. So, but let's, the holistically, antimicrobial resistance, what does it say? To a layman, should anybody watching this get to understand about this, especially our audience in Africa?
Okay. Now, for us to understand what antimicrobial resistance is, I think it's important we understand what antimicrobial agents are. Agents. And these are molecules, medical molecules for treatment of microbial diseases. And what does this mean? There are some little things we do not see with our korokoro eyes in a very simple Nigerian language uh, that cause diseases. For instance, if someone has, let's say, sneezing or cough, you are seeing the cough, but you're not seeing the effect of the cough. Now, there are drugs that can help to stop that cough. I'm trying to make it as simple as possible.
Right.
Now, these drugs work in a particular way. They don't just work all the way like one drug does everything. No, each drug has its own what we call targets of action. And so at each point, a drug does a particular thing to a particular agent. So if someone that is sick, let's say with cough or what we call flu, is given a particular drug, the drug works in a way by attacking what is causing the cough. And so normally these agents, I'll call them pathogens, these pathogenic agents are stopped by these drugs in a very simple language. However, at some other time, we know that the agent is there. The drug is also the same drug. It has not changed. But suddenly, the drug is no longer working. The drug that worked last year, worked last month on a particular infection or disease, suddenly stops working. The question is, what happened? Does it mean that the drug has lost its focus or the drug has gone on retirement? No way. That is not what happens. In microbial world, we understand that these pathogens are what cause diseases. Okay? In this case, if we call them microbial pathogens, what we're trying to say is we cannot see them with our naked eyes.
Right.
So these pathogens that cause diseases have decided to modify themselves in a way to fight these drugs. So ordinarily, the pathogens are stopped by the drugs in a very simple language.
Right.
But suddenly, the drugs are no longer working. The
So,
same drug,
in other
the same
words,
pathogen that had worked before stops working. In that case, we say, it seems we have a resistance in our hands. So
okay.
when a previously susceptible pathogen becomes, evasive to a given antibiotic or antimicrobial, now those two things are different. When I use the word antimicrobial, what I mean is anything that can attack any kind of infection, whether those infections could be fungi or bacteria. As we go along, we understand better. But the most important thing, which is the answer to your question, is a drug that worked before on a particular microbial pathogen suddenly stops working.
Okay.
Has the drug gone expired? No. The drug is working, but something has happened with the microbe. So we say there is a resistance going on.
All right. Thank you very much for that response. And to make it clearer, you've mentioned that antimicrobials could be against bacteria, against fungi, against viruses, also parasites. So the drugs that has to
Yes,
do with
please.
that. So now, in our climb, what are the things that could make this happen? Of course, we know that the pathogens on their own could be trying to adapt and fight back and resist being killed by these drugs. But are there things that we do either as clinicians, either as care providers within the hospitals, also as patients, or as human beings, interaction between man and the environment that tend to promote these changes that occur in the pathogen leading to the resistance?
Yes, I think this is an important question, particularly for our viewers and in general in public health. What do we do that aids resistance? There are many of them. One of them is when you begin to use an antibiotic or antimicrobial sporadically. What does that mean? What it means is, one is you buy a drug from any source without a professional prescribing the drug. So you can commonly get them anywhere, and then you use them anyhow. When you do that, microbes in the environment would most likely get adapted to them and become resistant. So one is sporadic use of antimicrobials in the context we are using it. Of course, there could be resistance in other areas, but I think that today our interest is antimicrobials.
Yeah.
There are anti-cancer resistant drugs and so many others. But for today, I think we are focused on antimicrobial.
Right.
So I will be focused on that in our discussion. So when you use drugs anyhow, you could contribute to that. Number two is, let's say a drug is prescribed by a doctor. A doctor gives you a drug, this is what you need. And then you don't finish the drug therapy. The regime you are given, the dose you are given, you didn't finish it and you stop taking it. Maybe because you think you've recovered from a particular illness. But by stopping the dosage, the bacteria can gain resistance, even within your body. Because the essence of therapy is not just to stop the bacteria from replicating, but also probably to kill the bacteria all through. So when you take a low dose of a given drug, maybe a drug that ordinarily will kill the bacteria, we call that bactericidal or antimicrobicidal, only performs a bacteriostatic action. That is, it can stop the bacteria from growing instead of killing it because the amount you took is not enough. So in that case, the bacteria can gain resistance.
Okay.
So one, as I mentioned in summary, is when you use drugs anyhow, unprescribed drugs. Two is you take drugs, you didn't take the dose, or even overtake the dose. The other one is the use of drugs in agriculture.
Okay.
In current agricultural settings today, there are drugs that are used for agricultural purposes. Now, these drugs has a capacity to get into so many ecosystems, like in our waterways. In our waterways, they can come in contact with bacteria. And these bacteria or microbes can gain resistance through that process and becomes a community problem. It becomes a public health challenge. As you mentioned in your introduction, antimicrobial resistance is one of the most difficult issues facing the World Health Organization today. So when we use antibiotics or drugs or antimicrobials, we need to be careful that these are what we're exposing ourselves to. Of course, drugs are good, but when you use them unprescribed, overprescribed, or illegitimately, you are exposing all of us to some dangers.
Right. Thank you very much. I really like the aspect of the use in agriculture. And by that, I assume for those who grow crops, because in agriculture, you have the plant part, they have the animal part. So can you throw more light on that? They use drugs to, in the farm, to grow certain kind of crops for it to get to environment. Those who grow animals, is there a way, use of drugs, veterinary use of medications, does it also pose a risk in antimicrobial resistance?
Yeah, if I understand you well, you're asking about the use of drugs in agriculture.
Yes.
Indeed, many drugs are being used today. Antiparasitic drugs, antifungi drugs, okay? Antibacterial drugs, antiprotozoal drugs, and many of them is used probably to even the use of pesticides. I did a research in published, I think in drug discovery and therapeutics, and that was in 2018. I did a research in 2018 where I found out that even the use of some weed or pesticides, weed controlling chemicals, okay, pesticides that ordinarily just for pests
Right.
can help Staphylococcus aureus. Now, Staphylococcus aureus is one of the major pathogens in clinics. You hear things like methicillin resistant or all those kind of jargons in medicine. But the truth is, Staphylococcus aureus, a very susceptible strain, can acquire resistance to antibiotics by exposure to pesticides.
Wow.
This is very important.
That's interesting.
This is the research I did myself that is already published. What I'm saying is, we have a Staphylococcus aureus, let's say that was susceptible to a certain drug, let's say chlorophenicol or flucloxacillin. Initially, we take the same Staphylococcus aureus, expose it to a certain pesticide.
Right.
This is what I'm talking about is published. They acquire almost 4 to 8 fold increase in their minimum inhibitory concentration. I think this is getting more academic now, as you claimed at the first.
Yeah, you know,
Almost 4 to
academics are
8
also
fold
watching.
increase in their minimum inhibitory concentration
Right.
to flucloxacillin and chlorophenicol. And do you know the problem with this? Now, what I realized in the course of my study was this was not just resistance to one drug. Initially, this bacteria was susceptible, a particular strain, I think RNN24 we call it, was susceptible at the beginning. Then we expose it to a parasite. We call it PKC parasite.
Right.
Or PKC with control. After exposure, we take it back to the laboratory and check their MIC in almost 12 drugs. And these drugs are clinically used. In almost 12 drugs, there was 2 to 8 fold increase in MIC just by simple
Exposure to
exposure.
the yeah. Okay. I think let's take a break here. It's a good start so far, and let's take a break here. When we return, we'll continue this conversation. I've been discussing antimicrobial resistance with Dr. Don Nwibo, who joined us from Preston in the UK. We'll be right back. Welcome back to Talking with Dr. Laz, your favorite health program on television, reaching you from Nigeria's capital city, Abuja. So we've been discussing antimicrobial resistance, one of the biggest challenges of public health. Of course, World Health Organization ranked it among top 10, and an associate professor has been with me, a researcher in this area with deep knowledge, and been dissecting it. So in this second segment, Dr. Nwibo, welcome back. Let's now talk about the consequences of this, in our practice. What made it got this classification? How does it affect the individual and medical practice as well as healthcare financing in Nigeria, especially in African region, where our health system is still struggling with a lot of issues?
Yeah, thank you, Dr. Laz. I think that the consequences are very dire, and I will try to make it as brief as possible. And now, it's difficult to isolate Nigeria and discuss because this is a global challenge. Everybody is equally affected. However, in the context of our country, we will also look at it in retrospect to what is obtained elsewhere. Because to be frank with you, it seems to me quite clearly that the level of attention we give to drug resistance, not just in Nigeria, but in the whole of Africa, leaves much to be desired. And I understand that the resources are very scanty, and this could be the issues. But what are the consequences? There is a research powered by former British Prime Minister, I think David Cameron, in 2015. The result of that research suggested that by 2050, if the trend of antimicrobial resistance as it is today is not curtailed, we could be losing 10 million deaths between now to 2050. This report was made available in 2016, and it's there in the internet. Global economy will lose almost $100 billion or $100 trillion in terms of money. That is huge. And it is a global problem. So more deaths might occur. How do I mean? One is when there is antimicrobial resistance, simple things that could be handled by drug therapy will fail. So we call that failure in therapeutics or therapeutic failure. There will be therapeutic failure. And there will be complications associated with that. The second is a simple visit to a clinic or a hospital that you're supposed to go, maybe get some therapy and come back, will become prolonged. Because the doctors, the nurses, and all the medics and paramedics are fighting to understand why the drug we used yesterday, which worked, suddenly stopped working today. So your stay will be prolonged. Of course, that means the length of time you will be sick as a person, or the patient will be sick in the clinic or in the hospital, will also be prolonged. Now, before the coming of antibiotics or antimicrobials, simple medical procedures, for instance, transplanting organs, let's say transplanting, someone needs kidney or heart transplant, wasn't possible. But the arrival of antibiotics, everybody shouted, hooray, we are there. Now, the problem is that we are going back to the pre-antibiotic era.
Where there's failure after those transplants.
What it means is that simple medical procedures like surgeries, simple surgeries, cannot be conducted because you risk the burden that you'll be infected. And when you're infected, you can't treat it because the available drugs are not working. And remember, drug discovery process is a very elongated procedure.
Right.
In short, I participated in my research during my PhD at the University of Tokyo in discovery of a certain drug in our laboratory and in my team. We call it licensing E. Between then and now, almost 5-6 years ago, the procedure has not even gotten to phase 2 of clinical trials.
Wow.
So it takes a long time for a drug to be discovered. So if the ones we have now are not working, it means simple chemotherapy will become complex. Organ transplantation cannot work.
Right.
Simple surgeries cannot work. But there's one that everybody needs to understand. And this is where our common discussion comes in. And that is the fact that there will be increased cost of Medicare. What does that mean? A drug you used yesterday, you bought it today, the doctor gave it to you, know that you used it illegally, and they are using it, it is not working. You have to go back to the clinic.
Yeah.
And then you spend more naira buying another kind of drug.
Right.
It will also lead to wastage because every drug that is available in the clinic is for a particular purpose. And here you are giving a drug A today because of resistance is not working. And then that one is wasted. And then tomorrow you come back and the doctor has to give you a new one and the pharmacist gives you a new one. You go back, probably it's not working because of resistance. And then you have to look for drug C. What does that mean? What it means is that we've wasted resources economically, we've wasted money, we've wasted time, we've wasted drugs, we've wasted research because each of those drugs, A, B, C, D, you just took a long of time to be discovered. That is somebody's effort.
Right.
So
Dr. Nwibo, we are running out of time. Yes, we are running out of time. Could you, within 60 seconds, talk about the solution, quick solutions? What do we need to do?
Well, yeah, quickly. I think that the solutions are very simple from what you can see. One is make sure for every drug you use, not just antibiotics, because today we are looking at antimicrobials.
Right.
But as you know, there are problems anti-cancer, exempting
Antiviral,
resistance, and all that.
antifungal, and all of that, yeah.
So make sure that the drugs you use are prescribed. That is one. Two, make sure that you use the drugs according to the prescription. If they say take it 4 times in a day or twice a day, take it that way. Finish that drug. Don't think, okay, I'm fine now. I don't need to take it after all. I'm feeling good. No, you are exposing both yourself and all of us to problem. For those who use drugs in agriculture, my advice is we need to see a collaboration between the clinicals and those in the agricultural sector. They need to be a collaboration so that we know that if we are using a weed or a pesticide, we know what amount do we use? What exactly do we need to use? There are professionals in those areas. It's not just anything you buy in the market, you put it in agriculture, gets into our ecosystem, destroys everything, and brings us problems. That is just my advice.
Okay. Okay, thank you very much, Dr. Daniel Nwibo. I know you still have a lot to say, but I think I'm going to bring you back on this program so that we now deep dive into the academic part. Today is more like, because there are some persons who are actually interested in this. I know we've been trying for a while to get you on this interview, but time hasn't quite allowed. But I'll re-invite you, and we get into the other slides with those mentioning the names of the drugs, the mechanism of actions, and at what stage some of these things play out. I really want to thank you for making out time to be on the program today.
Thank you for having me, and I apologize for the time we wasted. It's not been easy, but
we didn't waste time at all. All right. So that's the much we can take today. I believe you learned a lot from the program. Those recommendations are key. But let me also add that selling antibiotics, antivirals, antifungi, antiparasitic drugs over the counter, that the regulatory organizations also need to take actions. While we expect people not to take them without prescription, those who are selling it should also not sell them without prescription. So the Pharmaceutical Council of Nigeria and other relevant regulatory authorities at the federal and state levels, please help to control the abuse of antibiotics and the sale of antibiotics without prescription from a healthcare professional. My name is Dr. Laz Ezes. We'll see you same station, same time next week. Bye for now.